Hey guys, I'm Mr. R, and this is the introduction to real numbers. Let's start this intro with a walk down memory lane. We're going to TBT it back to when we're learning how to count with Dora. And it was simple at the start. We started with 1 and then came 2 and 3 and 4, 5 and 6, and we worked our way to 10 and we were like, cool, we got this. And you learned some bigger numbers. You got numbers like 12 and you got numbers like 21, and we got some little numbers like 0, which is pretty important, it turns out. And everything is good. Later on, we get a bit older and we learn how to do things like addition and subtraction, but then we're given this warning by our teachers. And so then we've got to be careful at how we do maths. While we can do 7 minus 2, and that's equal to 5, we're told we can't do 2 minus 7, because the 7's bigger than the 2, and that doesn't work. And we're like, okay, cool, we're adaptable, I can roll with that, no worries. Until a couple of years later, you learn about negative numbers and you realize, what? I've been lied to. But we deal, and we progress, and we learn how to do things like multiplication and division, and sometimes it's good if it goes evenly, but sometimes it doesn't go evenly, and we're told we can't do that. And then we learn things like decimals and negative decimals and fractions. And we realize, hey, we've been lied to again. But even though we've been lied to this whole time, our understanding of mathematics has developed, and our knowledge of these different systems of numbers has also started to be formed. Back when we started to count, we started with these things called positive whole numbers, and we call them our natural numbers. We then introduced 0, and we got negative whole numbers, and they're our integers. And then we got decimals, and decimals which recur, and fractions, and they're our rational numbers. But given that we've been lied to this whole time, I'm sure we're all expecting, hey, there are some numbers that don't necessarily fit this model exactly. And I'm sure we've seen some of them before. And what's the deal with them? Well, we call them irrational numbers. Irrational numbers cannot be expressed as a fraction. They are non-terminating, non-recurring decimals. Let's break that down for a second. Terminating means something ends. It does not go on forever. Recurring means it repeats over and over and over again. So basically, irrational numbers are the crazy ex-girlfriend of numbers. They are super hard to express simply, and they just go on and on and on and on. Let's take a look at what some of them look like. Terminating means it ends, doesn't going on forever. Some examples of that are decimals like 1.2, 2.5675, negative 3.54342, negative 10. These are all decimals that terminate. They are not irrational, they are rational. Decimals which do not terminate or go on forever are things like 2.4958 on and on and on, or negative 2.567 recurring. They do not terminate, they go on forever. Something which recurs repeats. Something like negative 2.567 recurs, or 5.123123 recurs. It repeats over and over and over again. Things that don't recur are your basic decimals like 4.678. Negative 9.291, they don't recur. Pi is an example of a number that does not recur. It also has the distinction, though, of not terminating, and that is an example of an irrational number we've already seen before. There's another class of irrational number, though, and we call them surds. Surds are a special type of irrational number which can only be expressed exactly as a root. So let's take a couple of roots, and we'll see what we can do with those. Square root of 4, well, we know that's positive or negative 2. That is an exact expression, so the square root of 4 is not a surd. Cubed root of 8 is 2, another exact expression, it's not a surd. But what about the square root of 5? Well, that's 2.3606 and goes on and on and on and on, and it never repeats, and it never ends. Well, that's a surd. It's an irrational number. Same deal with the fifth root of 12. It's somewhere between 1 and 2, it never repeats, and it never stops. That's an irrational number, and it's a surd. So let's recap. Irrational numbers cannot be expressed as a fraction. They are non-terminating, which means they never end, and they are non-recurring, which means they never repeat. And surds are a special type of irrational number which can only be expressed exactly as a root. Guys, I'm Mr. R. This has been the Intro to Real Numbers. Thanks for watching, and I'll see you again soon.